All right, so this video is going to demonstrate multiple functions, and these are just different labs that I give out to my high school Java kids for recursion. Now, some of these recursion problems I'm going to do here, but they involve like strings, and we haven't, the way that the book is set up for this Python class, the strings we don't get into until later in the semester. So if you don't know anything about strings, you might just want to skip parts of this video. I am going to do a multiplication problem recursively, Fibonacci sequence recursively, printing a string backwards, that's going to be recursive instead of a loop. And so this is a string. Palindrome, that's also a string. And we'll do this decimal to binary numbers recursively, okay? So, all right, so I'm going to start off and do recursive multiplication. So I'm going to open up an IDLE, and I am going to call this video, or this project, I'm going to call it file new, file save as, and I am going to call it, I don't know, recursive labs. No, recursive lab problems. How about that? That's a good one. Recursive lab problems. All right, so, and by the way, this is my second video for recursion. I go through another video. And so let's see here. We want to do the recursive multiplication. So, these are just different multiplication problems that they have. Now, let's think about multiplication real quick. And I'll be opening up there we go. See if they just open up a whiteboard. So, when you think about like multiplication, let's say I have, is it going to, I don't know why that's not working, sorry. If this doesn't work, I'm going to pause it and I'll figure out what's going on, and then it could be my draw a shape to create a screen. Okay. Alright, I'm pausing, so I think my battery might be dead on this. Alright, so my pen isn't going to work, so I'll just use this and type things out, and it might not be as clean as a pen. But when we think about multiplication, let's say we have two numbers. We have a 7 and we have a 4. Now, from a young age, we know 7 times 4 is 28. But what's really happening here? Really, what's happening is it's saying you're either taking 4 sets of 7 and adding them together, or you could do it the other way around. You'd have 7 sets of 4. Okay. Either way, whatever way you want to do it, but that's what's happening with multiplication. All right. So what we're going to do is we're going to write a method that solves multiplication recursively. So let's say I have an x equals 7 and a y equals 4. And we wanted to create our first define mult recursion. Okay. And we would pass in the x and the y, right? Okay, so if x is equal to 0, then we would return 0. else, now let's think about this now. So we want to print, and I'll just do, you know, strx times stry, and then we want mult recursion x and y, and I'm going to make that a string because I'm going to bring back the answer str. Okay, now let's think about this. What are we doing here? We're taking the value of x and we are basically adding it up. So we would do return the value of x plus mult recursion, and then we'd pass in that value of x each time, so we'd pass 7 each time, but we want to be able to do it 1 less each time, so we want to do it 4 times, so 4, 3, 2, and then 1. So we would do what? Well, actually, you know what? I think this needs to be the y. But then we would do what? Y minus 1? Y minus 1. Because each time it'd be... So this first time when I passed 4 into y, 4 minus 1 would be 3. And then it would go up here and you'd have 7, 3. So each time x is 7. And so it'd be 7 plus 7 plus 7 plus 7, and then it would hit 0 and it would return 0. So let's just try this real quick. I think this is right. 7 times 4 plus that mult recursion is not defined. Probably spelled it wrong. Alright, I had a printer also go off in my room, so I'm going to pause it so I don't have to hear this while the video's going. Alright, sorry about that. My office mate is now done printing, so we'll get back to this. So, I think we had an error. What was the error? Alright, mult recursion. I'm spelling it wrong, so it's probably this one right here. We'll run this. 7 times... okay, so let's do this equals, so do a plus here. Okay, cool. So I don't have my normal pen, so I'm gonna have to do it with my finger here, but I'll show you this. So it's basically 7 plus, and then it's the recursion, and then I pass in this 7 comma, and then originally it was 4 minus 1, okay, which is really 3, okay. So it gets passed in, and then you do another one, 7 plus the recursion, 7, and then it's 3 minus 1, which is 2, right? And then you do same thing, 7 plus r, which is 7, comma, 2 minus 1, which is 1, and then 7 plus r, 7 comma 1 minus 1 is 0. And so the 0 returns 0. So then this whole thing right here, remember it returns 0. This whole thing is 0. So it'd be 7 plus 0. And that's 7. So this 7 is this whole thing right here. Okay, this whole thing. So then I have 7 plus 7 equals 14. And this 14 is the whole thing here. So you do 7 plus 14 equals 21. And this 21 is the recursive value of this whole thing. So you got 7 plus 21 equals 28. So 28 is your final answer, okay? And that's really hard to write out with the mouse. Well, I don't have even a mouse. So, I don't know what this is, so I'll close that. Alright, so that's that. So next up is the Fibonacci. Now this is definitely weird, alright? So we're going to call this Alright, so when we look at Fibonacci, this is the position, and this is what we're going to enter. We're going to enter our position. So like if we enter 5, the way that Fibonacci works is the first two positions. So if your position is 0, 1, you return the position 0 or 1. But as you go, so like this is equal to the previous 2. So 2 is equal to 0 plus 1, which is 1. Position 3 is equal to the previous 2. So 1 plus 1 is 2. This is equal to the previous 2. 1 plus 2. Again, previous 2. 2 plus 3. So if you think about it like that, this is not that hard, but it is a little bit funky. So we're going to pass in our position. So print okay, so we're going to pass in our position, and let's just call our position position's 5, let's say. Okay. We do string and I'll just do, I don't know, recursive Fibonacci. And okay, so if equals a 0, you could say it's equal to 0. I'm just going to say less than or equal to 1. Okay. Then return position, else return. So we want we want the beginning one, or the previous one, and the one before that. So we want our recursive Fibonacci, the position -1, so we want the one right before it, -1, so that 3 right there, and the one before that. So then we would do plus recursive Fibonacci position -2. I think this will work. Run. Position is not defined. There we go. Oh, I didn't mean to put that like that. I meant to say position equals 5. Run. Alright, return that and that. Recursive Fibonacci is not defined. Okay, so let's... I'm just spelling it recursive. Again, watch your... Okay, so we've got that. Let's try 7. 13. So... Okay, cool. Alright, so... And again, like I said, I would just think about this as just, you know, you're taking the previous... So you take your position, which is 5, minus 1 is 4, and then minus 2 would be 3. And so then, you know, that's that. So next up, we'll print a string backwards, okay? So we'll just do... let's say we have a word, and that word is Python. So printing it backwards, we'll do print word. Say backwards. Word variable plus, and then backwards, and pass the word in. So define backwards the word, and what we want to do to get out of the recursive loop is if the word is equal to blank, meaning that there's no more, that there's nothing in the word, then we just return the word. Else, now this is where I've got all sorts of videos on strings and slices and stuff, so you might want to come back to this later in the semester, alright? But we're going to say backwards, and we're going to have our word, and we're going to take what's at position 1 to the end, okay? And then we'll add on our word at position 0, okay? So, let's see here. Let's say we've got our word equals Python, okay? If we wanted to look at the index of this, 0, 1, 2, 3, 4, 5, okay? So, starting at position 1 to the end gives us Y, T-O-N, and the P is at position 0. So each time it will look something like this. It will take this and pass it in. So backwards, we'll take the word basically next time, all right? And then what's that position S? So word at position 0 is this uppercase P, right? And so that gets that's not being passed in. So each time it's going to take, and then so the next one it would be basically, and that would be what? Y is at position 0 this time, and backwards would take THON. And if I were to just type this all out at once, I can show you kind of, then HON, ON, N, and then it's blank this time. So the blank is our if statement that gets us out of here. We return the word. So basically we would have TON here, and that would be a T, and then we got HON, and that would give us our H. We got ON, and that gives us our O, and then we got our N, which gives us our N. All right, and then it looks like it's spelling it out from the beginning, but when you recursively do this, you have to kind of go backwards after you're done going forwards. And then so you basically go N, O, H, T, Y, P. So if I run this right now, we'll see if it works. Everything I've done so far, it blows up because I spelled things wrong. Backwards, okay, word equals word. I need a plus there. So Python backwards word variable NOHTYP, so that works. Extra space there. All right, so that was a pretty easy one. Now again, this was all in Java, but that's how you do this. Now a palindrome is a word that is spelled the same forwards as it is backwards. So we're going to check to see if a word is a palindrome. So the classic palindrome is, so we'll just say word 2 is race car. All right, so we could do print word 2 moving to word 2 is a palindrome, and then we'll do a str, and we'll do is palindrome, and we'll return, true or false. Okay, so we'll just say word 2. All right, so define is palindrome, pass in word 2, and so if the word is less than 2, meaning it's one word, like the letter I, so I is a palindrome. So that's the first check. So if the length of word 2 is less than 2, then return true. Okay. Else if no. So we'll just keep that like that. So next is if our word at position 0, okay, so position 0 is where our, so for this one, we've got word 2 equals race car. And so we've got our index, so 0, 1, 2, 3, 4, 5, 6. Now, what's cool about Python with strings that you don't see in like Java is that this, if you were to go backwards, is also, and maybe I spread this out so that I can put my negatives in, okay? So imagine those spaces weren't there, all right? What Python allows you to do is to index backwards. So this R is either 6 in position 6 going forward, or it's -1 going backwards, all right? So what I can do here is I can say if word at position 0 is not equal to word, I need to say word 2 here, I'll get that screwed up. Word 2 is not equal to, what's that, -1, then return false. Okay, and then I just need to do return is palindrome word 2, and this is a little bit funky as well. 1, -1, or not 1, 1, -1. So what's happening here? Now the way the slices work, okay. For instance, so if I look at this down here, and let me just copy that in there. What's going to be passed in is it's going to start at 1, and then it says -1, but the way that the slices work is it goes to the everything in between, but not including the -1. So it would be, so this would return A, C, E, C, A. So position 1, A, C, E, and then CA, okay? So that gets repassed back into, here, and now word 2, so is palindrome, would be passing basically that into it, okay? And then if you do this word 2 again, then what we're going to get is, here's our index. We got 0, 1, 2, 3, 4, but if I spread this out again, we've got what? -1, 2, 3, 4, 5. So we got -5, -4, -3, -2, -1. Okay, so then it would do 1 to this, and so you'd have, is palindrome, and then we would have, CEC, and then you would do kind of the same thing here again with our that going down here, and then so instead of that it would look like this, right? And then you know, and then 1 to -1 would just give us our E right here, right? And so then is palindrome, and I'm basically passing E to it, right? And then so is our palindrome word, the length of the word less than 2? Yes, so then it would return true. So let's check this. Yeah. Okay, let's try that again. Race car is a palindrome. Now if I change race car to Python, Python is not a palindrome. Python. So it should return false. Okay, there we go. So that's done. Alright, so palindrome. And last one, decimal to binary. Now, you know, I'm not sure who's familiar with decimal and binary, but let's go. So basically, the way that binary works, let's do this real quick. Full screen. Alright, so the way that binary works is you got 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, and I'm not going to do a lot of these because it's, you know, the lesson isn't necessarily that you understand. Well, again, and we went through binary numbers in here, so this, you know, you guys should have a good idea of how the number systems work. So this is 1, this is 2, this is 4, and then this is 8, right? And then so you know, whether these are on or off, okay? Let's say we had the number 6. What in here represents the number 6? It's a 4 and a 2. So our binary number, that would be on, that would be on, and that would be off, okay? Let's say we had the number 5. 5 would be 4 and 1. These are the decimal numbers. 4 plus 1 equals 5. So that would be on, that would be off, and that would be on, okay? So what we want to do is we want to pass in a decimal number and return the binary number. Well, how do we do that? Well, you know, we've got 6 divided by 2 gives us, let's see here, that gives us 3, right? And then 6 modulus 2 equals 0, all right? And then we would do 3 divided by 2. That would give us 1, okay, because we're working with integers. When you do them out, you don't get 1.5, you just get 1. And then 3 modulus 2, that gives us 1, okay? So this is our, now we have to do the division, but you know, this is our binary number that we're going to come up with. So then we do 1 divided by 1 equals 1 divided by 1. Am I screwing this up? 2 divided by 2, 1 divided by 1 equals 1, and 1 modulus 1 equals 0. So let's see here. I think I screwed something up. Let me think here for a second. Let me come back to this, alright? And see if I messed something up in my head. So I'm going to define my binary converter. Okay. And I'm going to just pass in a number. And let's just assume this number is 6. So number equals 6. So I'll say print str number plus converted to binary is then I'm going to do binary converter. I'm going to print that below it. All right, print. Okay, so let me think here. So if number is greater than 0, then I'm going to do binary converter, and I'm going to do int, and I'll do number divided by 2, and I will print number modulus 2, and we'll end it. Okay, so alright, so we got binary converter, and then I'm going to pass the number into it. And so if I run this, 110 none. Alright, since I printed it in here, I actually don't need that print, and that's why there's that none displaying. So run that. Alright, so pause. Alright, and now let me go back here. I think I made a mistake here. I think what I wanted to do here was to make that a 2, right? Not a, sorry. Let me use my, I screwed up with that, and this needs to be divided by 2, and this needs to be modulus 2. And this will make more sense here. So I did 2 on all of them, so I did it right. So 6 divided by 2 is 3. 6 modulus 2, 2 goes into 6 3 times with the remainder of 0. Then I take this 3 and I've got, you know, and I'm doing that because look at, in here, 6 divided by 2 is 3, so 3 gets passed back in here, and then 3 divided by 2 is going to be 1. 1 gets passed in here. 1 divided by 2 is going to give me 0. So 0 gets passed in. Is number greater than 0? No. So that ends it. So back to this. 3 divided by 2 is 1. Then I do 3 modulus 2. 2 goes into 3 one time with the remainder 1. And then 1 divided by 2 is 0. And then 1 modulus 2, the rule is if the left-hand side number is less than the right-hand side number, then I need to do a 1 right there. 1's the remainder. So see here. So the answer is 1, 1, 0. So that's what we got right there, right? 1, 1, 0. So now if it's 5, we'd have 5 divided by 2. And that's going to equal 2.5, right? But it's really just 2. And then 5 modulus 2. Is that's going to equal what? 1. And then 2 divided by 2 equals 1. This needs to be modulus. Sorry everybody, it's hard. It's super hard writing with this without a pen. Okay, so that's our last number. 2 divided by 2 is 1. And then 2 modulus 2. 2 goes into 2. 2 goes into 2 one time with a remainder of 0. So there's that. And then what? 1 divided by 2 equals 0. And then 1 modulus 2. The left-hand side is less than the right-hand side, so we return the left-hand side of 1. So it equals 1. So then if we go back up the stack, this one is 1. This one is 0. And then this one is 1. So that's our final answer, 101. So let's make sure and just plug that in real quick. So, I don't know, number is 5. We should get 101 for a binary number. 101. Okay, cool. So that works. Alright, so these are all the different kind of labs that I go through with my AP Kids, and so this should give you some good practice with, 4 different recursion problems that are decently difficult, but not too bad. So anyway, this video is done.